So today we're going to be solving a system of linear equations by graphing. What exactly is a system of linear equations? Well, a linear equation is an equation in the form of y equals mx plus b. And when you have a system, it's literally the plural form. So when you have more than one, it's called a system in math. Instead of a pair or a group of equations, we call them a system. So let's write that down. System of linear equations is just a set of two or more linear equations in the same variables. We might think of it as a group, a couple, a few, but in math we call it a system. A set of two or more linear equations And what it means by in the same variables, meaning both equations will have the same variable. For example, if the first equation has an x and a y, then the second equation will also consist of an x and a y. So I'll show you what an example of one looks like. But let's also discuss what a solution is. Well, let me show you first here. So usually you'll see some brackets or just a list of equations. So let's say I have y equals 2x plus 4, and then maybe so that is considered a system of equations because it is two equations. They both have x and a y, so they have the same variables. So what would be a solution to this? So what would a solution of a linear equations be? It would literally look like the form, right over here. A solution would take the form of a coordinate point. So whenever you find a solution, it's going to look like a coordinate pair because the x and the y together are the same x and y that work when you plug the y and the x here, the same x and the same y here. You will notice that both equations are satisfied, so therefore it would be a solution. And the method that we're going to use today is finding that point by graphing. So let's go ahead and write down what the solution is. It's an ordered pair that is a solution to both equations or each equation. All right, so let's look at example 1. We're going to solve by graphing. And we're given the system of equations y equals 2x plus 5 and y equals negative 4x minus 1. Now when we're doing solving by graphing, it is very important to have graph paper because we're going to be looking for the exact intersection. And if you're just making a random graph on line paper without any grid lines, then it's harder for you to continue the slope in a correct pattern. So to graph this, same thing we've done before, is using your intercept and your slope is the most popular and common way. So for the first equation, I'm going to say that my y-intercept is going to be 5 and my slope is 2 or 2 over 1. And then the second equation I'm going to graph. Second equation would be the y-intercept of -1, and the slope is -4. Okay, so with that information, we're going to go ahead and create our graph. All right, and I'm going to color code the equation so we can tell which one's which. So we'll say this one I'm going to do green, and this one I'll do in red. So first, the green line. I'm going to start on the y-axis at 5. So that means I'm going to be here. 1, 2, 3, 4, 5. And then my slope says up to over 1. So let me make this a little longer. So I'm going to go up to right 1. From 5 up to over 1. So this is my line. And I'm going to continue that pattern because I do want to find an intersection at some point, and it cannot be a crooked line, so it has to be continuous. The slope will be the same throughout the entire line. So if I see 2, 1, 2, 1, 2, 1, 2, 1, 2 down, 1 over. So there you go. Very, very important to keep this line accurate. Now let's do the red one. Starting at -1 as my y-intercept. And then I see that my slope means down 4, it's negative, and 1 to the right. So down 4 and 1 to the right. Now if I want to continue my slope, I'm not going to keep going down because I know it's going to cross somewhere over here. So I want to go backwards this way. So if I have 4, 1, it's going to go 1, 2, 3, 4 in this pattern. 1, 1, 2, 3, 4, 1. So my line should look like this. All right. So now, if I'm asking you, where do these two lines intersect? The red and the green line. It looks like their intersection point is right here. That is the solution. Right? Because out of all the points on this red line that satisfy this equation, and out of all the green points on this line that satisfy this equation, there's only one that they both share in common that's going to satisfy both of them at the same time, and it's this one here where they both have the same x and y, which would be -1 and 3. We can also say x equals -1 and y equals 3. So that would be your solution. All right? And that's the method of graphing. So if you remember, when you have lines, there's infinitely many points on every line. And out of all those infinitely many points, there's only one special point that both of them share in common. And when you take that special point, you know that it's going to work in this equation and this equation. So we're going to go ahead and plug it in and check to see and confirm if it is really truly our answer by plugging in and checking. So the first equation was y equals 2x plus 5. And our second equation was y equals -4x minus 1. So I'm going to plug in my y and my x. And same thing here. And I'm just going to prove to you that in both equations, that point is a solution. So for x -1, the y has to be 3. The y has to be 3. So is it true that 2 times -1, which is -2, plus 5 equals 3? Yes. So it worked in our first equation. Now when I plugged in -1 and 3 in my second equation, -4 times -1 is +4 minus 1. That does give me 3. And again, it checked. So I just confirmed that this is truly the solution to this equation and this one, because here we showed me that you plugged in x, plugged in the y value, and it worked. All right, so let's look at example 2. Just giving you the information so we don't have to write so much. It's about a test, and it's got 10 questions. Test questions, 3 points for every word problem completed or corrected, done correctly. And you will also be earning 1 point for each computation problem done correctly. All right, and there are a total of 18 points on the test. And the question is, how many word problems were there? All right, so given all that information, we have to identify our unknowns. Well, clearly the question's asking for how many word problems, so we don't know how many word problems there were. But aside from that, we also don't know how many computation problems there were. We just know that altogether there was 10 questions. So the first thing you do in any problem is you want to let the teacher know, the one who's grading your paper, what your variables are representing. So we want to say that we're going to let our variables equal what? So let's let x stand for total number of computation problems. And then we're going to let our y equal our total number of word problems. Oops, not abbreviated. Oh well. All right. So now, therefore, when we see x and y in our equations, we know what they stand for and what they represent. So as we read this, we're going to have two equations, and equations will have equal signs at the end of them. So as you're writing your equations, you want to think to yourself, what is the total? It's equaling what? So we do know that we have two totals in our problem, 10 questions total and 18 points total. So I'm going to leave my totals over here. Something's adding up to 10, something's adding up to 18. 10, I'm going to write on the side 10 problems. And for 18, that stands for 18 total points. All right. So we're going to start to compile what are we adding that gives us 10 problems. Our word problems and our computation problems. All together makes 10 problems. So let's write that down. Instead of writing it out, we're going to use our variables. Total number of computation problems plus our total number of word problems. Okay? So that's what it says. Total number of computation problems plus total number of your word problems equals 10 problems on the test. And then now on the bottom, how do I figure out how much I earned just by doing all my computation problems? If each computation problem was 1 point, then it's going to be 1 point for every computation problem. There's an invisible 1 here. I'm not going to write it down. Plus, how many points did I get for just doing all the word problems? 3 points for each word problem. So that means I'm going to get 3 points times the number of word problems on the test. Okay, this is assuming you get them all right, or the teacher's choosing to make it out of. That is your system of equations. Okay? One of them is regarding total number of points is your focus. The other one is regarding total number of problems as your focus. So now that we have these set up, we're going to graph them and see where they intersect to find out how many word problems we had. So I'll write them out here because they are not in slope-intercept form. You could make a t-table, but I'm just going to separate them here. And my goal is to get them into slope-intercept form because personally that's the easiest way I can graph lines. So subtract x and I get y equals mx goes first plus b. Then over here, subtract x, 3y equals negative x plus 18. That's the m term, then the b term, so I switched them around. And then I still got to get rid of my 3. And that leaves me with y invisible 1. 1y equals 1/3 negative x plus, that would be 6. All right, so now we're ready to graph those. All right, so graphing the first one first, y-intercept is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My slope is negative 1, 1. So there's invisible 1, 1 here. So I'm going to go down 1 over 1. Okay, let me just write that down so we know what I did. A little recap. So this means for this one, my y-intercept was 10. My slope was negative 1 over 1. Okay, that's why I started at 10 and I went down 1 over 1. Now, because I do want to find the intersection, I'm going to continue the pattern as straight as possible. And then the other line. For that one, we have a y-intercept of 6, and we have our slope of negative 1/3. So down 1, 3 to the right. So let's go ahead and start at 6. 1, 2, 3, 4, 5, 6. Then down 1, 3 to the right. So keep that pattern going. Down 1, 3 to the right. Down 1, 3 to the right. Down 1, 3 to the right. And then I'm going to trace that line as neatly as you can. And then this clearly is my solution. That's where both lines cross. That's where they have a common solution to both of the equations. So we're going to go ahead and label this as 1, 2, 3, 4, 5, 6, 4. Now, which of these coordinates represents my my word problems? Let's go back up here. Word problems was our y coordinate. So that means we had 4 word problems. On the test, and 6 computation problems. And there you go. You can plug it in and check. 6 and 4. Is 6 plus 4 equal to 10? Yes, it is. And if you had 4 word problems, that would be 12. Plus 6 would be 18. So they checked. All right, and there you go.